Good morning, my dear students. Today, I am going to give you an introduction about electrostatics. You have already completed 10th class and you know the fundamentals of current electricity. But today, I am going to discuss electrostatics. Electrostatics means the study of the properties of charges which are not moving, that is, charges at rest. Before going into the details of electrostatics, we have to understand very clearly what is this charge. So first I am going to discuss electric charge. We know that electric charge is an intrinsic fundamental property of certain fundamental particles. So charge is an intrinsic property of certain fundamental particles. For us, we can take electrons and protons as fundamental particles. The type of charge associated with a proton we call as positive charge, and the type of charge that is associated with an electron we call as negative charge. The reason the two different types of charge exist because we can understand from a simple experiment that when you bring two electrons nearby, it is found to repel. But if you bring an electron near to a proton, the result is attraction. Similarly, two protons also repel, but a proton attracts an electron. So there are two types of charges. The charge associated with electron we call as positive charge, and the charge associated with an electron we call as a negative charge. So the first property of the charge is there are two types of charges. And the second property already have told you, like charges repel and unlike charges attract. So the second property is regarding the force between two charges. Like charges repel. A positive charge repels a positive charge and a positive charge attracts a negative charge. That is the second property. Then what is this charge? See, this charge, which is an intrinsic property of electron, is a property which you cannot remove from that electron. You can never expect the charge and electron to be separated, and you can never have an electron without charge. It is an intrinsic property. I will give a small example to understand it very clearly. You just consider a boy who is 15 years of age and of 1.5 meter tall. Can you remove his age and make him ageless? Can you remove his height and make him heightless? Absolutely not possible, because they are the intrinsic properties of that boy. But you can remove his specs, shirt, pen or anything. They are not intrinsic properties. Like that, charge is an intrinsic property of certain fundamental particles and you cannot remove it. For us, we can consider electron and proton as fundamental particles. So that means we are arriving at the third property, that these charges are always associated with a mass. That means you cannot have a mass separate and charge separate. You cannot remove the charge from a mass. That's the third property. Then the next property is regarding quantization of charges. Quantization. Charges are quantized. To understand it very clearly, I will give you a small example. You just consider few steps leading to the first floor. Each step is 20 centimeter high. And a boy is standing here. A very obedient boy. I am asking him, I going to go up by 40 centimeter. What he will do? He will climb 2 steps up. If I ask him, you come down by 40 centimeter, he will come down by 2 steps. But if I ask him, you go up by 30 centimeter, can you do that? He can either climb 20 or 40. He cannot climb 30. Here we say that the height is quantized. He can climb only in steps of 20 centimeter. So the quantum of height here which he can go up or come down is 20 centimeter. That's a minimum quantity which he can go up or come down is 20 centimeter. Like that, the minimum charge that can be increased or decreased in a body is the charge of an electron or a proton. Even though the protons are very heavy compared with electrons, the charge associated with electrons and protons are equal in magnitude but different in sign. Soon you will be understanding that this charge, which is represented by plus E for the electron and minus for the proton and minus E for the electron, both are having a value of 1.6 into 10 raised to minus 19 coulomb. I will be shortly understanding this, and you have studied this value in your 10th class also. So the charges are quantized. See, you can increase or decrease the charge of a body only in steps of this charge. Then how to charge a body? See, I have a body here. You just consider a metallic sphere. This body I want to charge. You know the basic electronic structure that there is a central nucleus consisting of protons and neutrons, and protons are positively charged and electrons are moving around the protons in circular orbits. Electrons are negatively charged. That is a structure. See, you cannot play with the protons. You cannot take out a proton from the nucleus, but you can remove an electron which is orbiting around the nucleus, and you can either remove an electron or you can add an electron. So an atom, usually it is in the ground state, it is electrically neutral. See, then an atom consists of certain positive charges at its nucleus and an equal negative charge is moving around it, and the atom remains neutral. You consider this pen, millions of atoms are there, millions of electrons are there, not millions, much more than that, and millions of protons are there, but the charge, the net charge possessed by this pen is zero. The reason equal positive charges are neutralized by equal negative charge. Then how to charge a body? Whenever I say that a body is charged, we are speaking about excess charge, that is additional charge given to the body. I can make this body negative by adding electrons. I am adding electrons and make this body negative. But if I want to make it positive, what I must do? I cannot add any protons. So for that, what I do is, I will remove electrons. So when I remove electrons from this body, the net electrical charge of this body becomes positive. If I add electrons to this body, the net electrical charge of this body becomes negative. So charging a body either positively or negatively is done using electrons. When you add electrons, the body becomes negatively charged. When you remove electrons, the body becomes positively charged. So when I add electrons or remove electrons, I can add only integral number of electrons. That means I can add Ne, where N is an integer. That is 1 electron, 2 electron, 3 electron, 4 electron or so. I cannot add 5.5 electrons. I cannot cut an electron into two parts. So either I can add 5 electrons or 6 electrons, or I can remove 6 electrons or 7 electrons. That is only in integral numbers, integral multiples of electron. So the charge possessed by this body, whether it is positive or negative, all are integral multiples of the charge possessed by an electron. You see, 1.6 into 10 raised to minus 19 coulomb is the magnitude of the charge possessed by an electron. So you can have the charge of a body as n into an integral number into this quantity. That is a charge of a body. That is another important property. Then you know that in physics we have quantities called as vectors and scalar. Whether the charge is a vector or scalar. See, if I say that this body is charged, nobody is going to ask us in which direction you are charged. Is it towards east, west, top, down, or anything? No, there are no such questions raised. So the next property is that charges are scalar, they are not vectors. Now, as you know that in this universe consists of a large number of objects, and all these objects are made using building blocks of atoms, and atoms contains protons and electrons, and protons are positively charged and electrons are negatively charged. You cannot create an electron, you cannot destroy an electron also, you cannot create a proton, and you cannot destroy a proton. That means the total charge in this universe possess can be considered as constant, because the reason is that you cannot create an electron or you cannot remove, you cannot create a proton. You cannot destroy an electron or you cannot destroy a proton. That means you can arrive at a law called conservation of charges. The total charge in this universe is conserved. You cannot create a charge or you cannot remove a charge. When I discharge a body, that means I am not destroying any charges. I am neutralizing the charge. Suppose the body is positive. If I want to make it neutral, I have to add electrons. If the body is negative and if I want to make it neutral, I have to remove electrons. So, these electrons are removed or added either to make a body charged or to make it neutral. You are not destroying any electrons or you are not destroying any protons. So, the total charge in this universe remains constant. That is the last property. The last property is regarding conservation of charges. Conservation of charges. The total charges in this universe remains a constant. So, we have gone through the fundamental properties of these electric charges, and now it is time to move to the next topic, that Coulomb's law. This Coulomb's law, which governs the force of interaction between the two charges. That's the next topic to be discussed. That we will be discussing in another video. Thank you.